Welcome to Essential Standard 6, lesson number 4. This is the second day of trigonometric ratios. Today we are going to be solving for a missing side. The first thing that we want to do is we want to do a warm-up to make sure that we understand what we were doing last time. So this warm-up should not take you very long. So if you would please pause the video and do these 3 warm-ups. Please pause it now. Okay, welcome back. So for number 1, we should have put our theta down here at angle K. That's where we are looking at. So we always label our 3 sides. Our hypotenuse does not matter where we put our theta. Remember, we'll never have our theta at the right angle. The side that does not touch angle K is the side JL, or the 6, so that is the opposite. And then the last one is our adjacent. So for the tangent of K, remember SOHCAHTOA. TOA is TOA. So tangent of K is opposite over adjacent. So the opposite is 6. The adjacent is 8. So we'd have 6 over 8. And we always simplify our fractions. So that answer would be 3/4. For number 2, it says the secant of angle K. So I'm able to keep that theta there at angle K. Remember, secant is 1 over the cosine of angle K. So that is the hypotenuse over the adjacent. So the hypotenuse is 10. The adjacent is 8. 10 over 8 simplifies to be 5/4. And then our last one talks about the sine of angle J. You notice that now we are changing our angle. So our theta is now at angle J. So that makes the 8 the opposite and the 6 the adjacent. Notice that the hypotenuse is still 10. So when it asks for the sine, sine is SOH for SOHCAHTOA. So that is opposite over hypotenuse, so that is 8 over 10, which simplifies to be 4/5. Now we are on to today's lesson. We want to find the length of BC. So we want to find the length of BC here. They give us the angle 15, so we're going to go ahead and put our theta here at 15 degrees and label our 3 sides. So this would be the hypotenuse. The side that doesn't touch it is the opposite. And this is our adjacent. If you're wondering if you could use angle A for your theta, yes you could. We would first find that angle to be 75 degrees and then label our triangle accordingly. It's just a little less work to put our theta at the angle that they give us. So now I want to look. If we label our side BC as X, so I know the opposite side that I'm given a value for that, and I want to find the adjacent side. So I look at my SOHCAHTOA, and I see that I have opposite and I want to find adjacent. The one that uses O and A is TOA. So I am going to choose to use tangent. Remember, I'm using tangent because I know the opposite and the adjacent. I know nothing about the hypotenuse, nor do I want to find the hypotenuse. That's why I'm not using sine or cosine. I normally will not write a function using secant, cosecant, or cotangent, just because those buttons are not on our calculator, so this makes it much easier to do. So inside of my tangent, remember it's always a function of an angle, we would say the tangent of 15 degrees, because that's where I put my theta, is equal to opposite over adjacent. So it's equal to 10.2 over X. Now if you recall back to the Getting Triggy With It video, when X is on bottom, you swap them. So we want, since our value of X is on the bottom of the fraction, we're going to write down X equals 10.2 divided by the tangent of 15 degrees. Now we are ready to plug it into our calculator. So if we grab our TI calculator, we turn it on. One thing that we always want to check is press the mode button. And if you arrow down twice, you can see that there's a radian function and a degree function. Everything that we do in geometry will be in degrees. It's not until we get to pre-calculus that half of the stuff that we do is in radians. So once you set it to degrees, you can press second and mode to quit out of that. And now we're set in degrees, so we're ready to plug this into our calculator. If you want to make it look like a fraction, you can do alpha y equals enter, and you can type it in just like it looks, 10.2 divided by, and you notice here there is a tangent button that we can press, so we type in the tangent of 15. Close your parenthesis, press enter, and we get 38.0669. It says round to the nearest hundredth. The hundredth is the second decimal place, so we'd have 38.06, and the number after the 6 is a number 5 or larger, so we'd have 38.07. And the label on that would be feet because it was a length of a side. Find the length of QR. So I'm going to put an X there where we're looking for QR. I'm going to go ahead and put my theta here at angle P and start to label. This one is a little tricky because the hypotenuse is down on the bottom. RP is the side opposite of the right angle, so that's the opposite. The side that does not touch the 63 degrees is the opposite, and the last one is the adjacent. So again, I'm going to highlight the one that they gave me was the 12.9, that's the hypotenuse, and I want to find the x, which is the opposite. So when I think about SOHCAHTOA, SOHCAHTOA, I am looking for opposite and hypotenuse. Opposite and hypotenuse is sine, so I'm going to choose to use the sine function to solve this problem. So I'm going to write the sine of my angle, so the sine of 63 degrees, is equal to the opposite, which is x, over the hypotenuse, which is 12.9. X is on top, so we multiply. So x is equal to 12.9 times the sine of 63 degrees. So we're just going to grab our calculator, and I've already set it to degrees, so I don't have to do that again. So I'm just going to take 12.9 times the sine of 63. Close my parenthesis, press enter, and I get 11.4939. It says to the nearest hundredth again, so 11.49, the number after the 9 is not 5 or larger, so 11.49. Again, I'm solving for a side, and this is labeled in centimeters, so that would be my answer for the second problem. For the third problem, find the length of FD. So I'm going to put my X there for FD. I'm again going to put my theta here at the 39 degrees and start labeling my sides. FD is my hypotenuse. DE is the side that doesn't touch my 39 degrees, so that's my opposite. And this is my adjacent. So I highlight again. I want to find the hypotenuse, and I know the adjacent. So I think back to SOHCAHTOA. Cosine is the one that uses A and H, so that's what I'm going to write my function in. So the cosine of 39 degrees is equal to adjacent over hypotenuse. So that is 20 over x. So I put the adjacent on top, the hypotenuse on bottom. Once again, x is on bottom, so I'm going to swap them. So x is equal to 20 divided by the cosine of 39 degrees. Grab the calculator, and we just can do this in alpha y equals inner form. You could just press the division sign. That doesn't matter. Some people just like to make sure that it looks just like it does on the paper, though, and that's just fine. And we get 25.735. It says to the nearest hundredth again, so we'd go 25.74. The label on that is meters, and I am done with this problem. The last problem here is about the Politzebahn in Switzerland. It's the world's steepest cog railway. Cog railway is a train that's ran by gears that are called cogs. You can think of them as fingers that lay down into the tracks, so that way the wheels don't slip. If you think about a regular train, the wheels are very slick and they can't climb very steep things. These are especially made for mountains. It says its steepest section makes an angle of about 25.6 degrees with the horizontal. So I'm going to start off drawing a horizontal line. And it says that it makes 25.6 degrees with the horizontal. So I'm going to label that as 25.6. And it rises about 0.9 kilometers. So how much it goes up would be vertical to the horizontal. So this over here is 0.9 kilometers. It wants to know to the nearest hundredth of a kilometer, how long is this section of railroad track? Well, if you think about it, the railroad would actually be traveling this section of the triangle. So we want to find that length. So I'm going to put my theta here at the 25.6 degrees and label my triangle. This would be my opposite, this would be my hypotenuse, and this would be my adjacent. So I'm looking here for the hypotenuse, and I know the opposite. So the function that uses opposite and hypotenuse is sine. So I'm going to write my function in terms of sine. So the sine of 25.6 degrees is equal to opposite over hypotenuse, so 0.9 over x. We see once again that x is on bottom, so I'm going to swap them. So x is equal to 0.9 divided by the sine of 25.6 degrees. So we grab our calculator. We are going to alpha y equals enter to do a fraction, and we are going to take 0.9 divided by the sine of 25.6. Press enter and we get 2.082, so to the nearest hundredth of a kilometer we'd have 2.08 kilometers. And we are done with this portion of the video. Thank you.